Okay, so today we're picking up kind of where we left off with polynomial functions. We're going to pick up with polynomial functions day 2. It's basically a lot of the same stuff that we've done before, just sort of adding it all together. And then I'm going to show you some things that you can do on the calculator that will help you to answer some of these questions. So the first thing we have is repeated zeros of polynomial functions. And this is what I was alluding to yesterday when I talked about multiplicity. Multiplicity tells us whenever we have a power, that tells us that we have like a double root or a repeated root. So the multiplicity, comes from the m, which I kind of didn't circle there. Basically what's that's telling us is that the multiplicity is if I have a parenthesis, like say if I had a function that was x minus 3 squared, the multiplicity would be 2 because that's the exponent that's there. And if I had like something that had an x minus 3 cubed, then that means the multiplicity would be a 3. So when we're talking about an even and an odd multiplicity, this is what we're talking about. So if it has an odd multiplicity, so like a 3, then the graph crosses the axis at x equals c, and the value of f of x changes. So that tells me I could have a graph kind of like a cubic function that could look something like this, where it crosses the axis something like here, and that's a change in the signs at x equals 0, going from a positive to a negative. If it has a multiplicity of an even number, then that tells me then it's going to have something that doesn't change signs. So sort of like if I had a parabola, I could have a parabola where it comes down and bounces back up again. So that would be an even multiplicity because it just doesn't cross over and go from a positive y value to a negative y value. So that would be what's going on there. So an even multiplicity looks like this one, and an odd multiplicity looks more like that one. So say, for instance, I have a function, and the function that I have is x times 3x plus 1 times x minus 2. And like we talked about yesterday, we would talk about the leading coefficient test, the leading term test. So when I do that, I'm going to figure out, is it going to be positive? Is it going to be negative? The leading coefficient. So, geez, all these things keep popping up. So what I would do with that is I would need to, if I wanted to, multiply all of that out, which really I don't need because all they want to know is the leading coefficient. So since all they want to know is the leading coefficient, I would look and see what are going to be the highest exponents of everything. Well, if I look, I would have an x, which is there. I would have a 3x, which is there. And then if I were to FOIL this out, I would end up with an x squared. So if I were to take x times 3x times x squared, which is what this says here, I would end up 3x to the 4th. So my degree in this polynomial would be to the 4th, and my leading coefficient would be a 3. Because it's even and has a leading coefficient that's positive, I can figure out my end behavior, which is what's right there. Then if I were to take that same function, so nothing's changing, it's still the same problem. There's my problem, it's the same one again. I want to determine the zeros. So if I were to determine the zeros, I would set each little piece equal to 0 and solve. So I would set the x equal to 0, the 3x plus 1 equal to 0, and the x minus 2 quantity squared equal to 0. Well, if I were to do that, x equals 0 would be the first one, and then the second one would be x equals negative 1/3 if I were to solve that equation, and then the next one would be x equals 2. Notice that since I have that exponent of a 2 up there, that's my multiplicity, so that means that x equals 2 has a multiplicity of 2. So as I was alluding to yesterday, that means the graph would come down to the x-axis at 2 and then bounce back up again. It's not going to cross the axis. So that's only what that question is talking about. Now, if again, I take that same question and I take it to the next step would be, well, what's the graph going to look like? Well, in order to figure out what the graph's going to look like, I'm going to have to get some more points. So I can create a table. So there's my table. I can pick different points that are in different intervals of my graph. So basically, since I know that my smallest 0 is negative 1/3, I want to pick something that's in the interval between negative infinity and negative 1/3. So I pick negative 1, I plug it in, I find out what value I get. Then the next interval I have goes between negative 1/3 and 0, because those are the next two zeros. So I can pick whatever number I want, so I happen to pick negative 0.1, I plug it in and I can get my value. Then the next two zeros, because I have 0 here, 0 to 2. So I'm going to pick something that's in the interval between 0 and 2. So that's 1. So that means I'm going to have 1, 4 if I were to plug that in. And then the last interval would be 2 to infinity. So I would plug in, say, a 3, and I could plug those in. Now, of course, I don't have to pick those particular points. You can pick whatever makes you happy, but those are the ones that I happen to pick. And then, of course, the next question will be, well, what would happen if I were to graph that? Because there's my equation, I have my zeros, I have my end behavior, I have my table, and if I were to graph it, lo and behold, there is my graph. Notice that I have my zeros like I found, -1, 1/3, and 0, and at 2. But notice that since it had a multiplicity of 2, the graph comes down, it goes down to the x-axis and then bounces back up again, and it never changes from a positive y to a negative y. That's what happens when it has an even multiplicity. So we'll talk more about graphing in the next class when you come to class. But of course, there's a little bit more because I couldn't just end it now at only 6 minutes. So here's our table. And in my table, I have a population over an 8-year period. Year 1 refers to 2001, year 2 is 2002, and so on and so forth. They want us to create a scatter plot of the data. Now, of course, I could do this by hand, but why would I want to? So instead, we're going to do it by using the calculator. So just to refresh your memory, if we haven't already discussed this before, in order to create that information, what I would do was I would go to Stat, I would go to number 1, Edit, and of course, I'm assuming that you have a Texas Instruments graphing calculator. The one that I have in front of me now has the old operating system on it. So there could be a little bit of things that are different if you have the new operating system or if you have one of the color ones, but it should be about the same for all of the calculators. So again, I hit Stat. I went to Edit. In line 1, I want to put the years. So I'm going to put the numbers in from 1 to 8 because those are my X values. My X values are going to go in line 1. Then I'm going to put in line 2 my Y values. So my Y values are going to be my population. And I just type those all in. It's going to take a little bit of time. So you might want to pause before I go on to the next step so that you can get the information plugged into your calculator. We're going to then determine the type of function that could be used to represent the data. So here we go, on to the next one. Again, if you need to pause, pause. So as it says, you're going to create a list, you're going to put it into L1, and then you're going to graph it. Once you graph it, you kind of need to guess, well, what kind of graph is it? Is it a parabola? Because if it were a parabola, I would be using a quadratic regression. Is it a line? Well, if it's a line, then I'm going to use a linear regression. Is it a cubic equation? Well, it happens to be a cubic equation. Remember, a cubic equation looks something like that. So in a cubic equation, I want to see, it kind of looks like that. So I'm going to do a cubic regression. The cubic regression will give us the equation of that particular function. So here we go for that. So we have the same information, nothing's new. Oh, then that really hasn't told me very much. So to get the cubic regression, what you're going to do is you're going to go back to Stat, you're going to go over to Calc, and then you're going to go down, and if you notice, there's linreg. Linreg is linear regression, so that gives us the equation of a line. Quadreg, which would give us the equation of a quadratic equation, like an x squared. A cubic regression, a quartic regression, then there's another linear regression, and then there's a whole bunch of other ones here, which we can use depending upon what they want. If they want power, if they want exponential, if they want linreg, well, natural log reg, which is if they're talking about an exponential equation with an e. But in this case, they say that they think that the equation is like a cubic. So I'm going to hit on my calculator, it's number 6. I believe it's like number 6 for all of them. So when you hit number 6, you're going to end up with an equation. And the equation that's going to pop up gives you an A, a B, a C, and a D. So those are parts of the numbers you're going to substitute in, probably round to the nearest thousandth. When you round to the nearest thousandth, that gives us the numbers that we would have for the equation, and that would give us what we need, which is fine and dandy. But we need to figure out, was that equation that we had, the best equation that I could get? Well, the best equation would have something that do with statistics. So if you're taking statistics, you might learn about this later. If not, you'll maybe learn about it some other time. But the statistics will tell us whether or not it's the best equation. And we do that by the coefficient of correlation. And we usually call that r squared. So we want to find out what r squared is. And that's what it says here. Write a polynomial function to model the data set, round each coefficient to the nearest thousandth, and state the correlation coefficient. The correlation coefficient, the closer it is to 1, or -1, otherwise known as the absolute value of 1, the better the equation is going to be. So we want to try to make it so that it is close to 1. So if I'm trying to figure out, well, is it a quadratic equation? Is it a cubic equation? Is it a polynomial equation? If that's the case, then you're going to try all those different equations, and whichever one has an r squared value closest to 1, that's going to be the equation that I want to use. Well, the next question would be, well, how do I find it? Well, we already said that you would do the cubic regression from the stat calc section. From there, I can actually graph it, so to see that it actually fits in the proper way. So in order to send the equation to the calculator based on the data, I would go to the y equals menu. You're going to pick up the regression by hitting vars. Then, oops, I'm looking at my calculator. I've got something different going on here. I'm going to go to vars. I'm going to go over to y vars, and I would hit number 1, and then I would put in the y1, and I think I'm telling you the wrong thing here. We're going to hit vars and then go down to statistics. There's another way to do it, and I guess this way is probably easier. If I go to y vars statistics and EQ, and the regression equation would go into that y equals section. So that way, whatever equation we had, which was the 10.020 x to the third, would just get picked up right from there and go in there. There's another way that we can also automatically send it to there, and when we get to class, I can always show you that. Once you do that, you can see that it fits pretty well. If it fits pretty well, that's good. You also want to check your r value function depending upon, r squared value. Depending upon your calculator and how it's set, you can turn on your diagnostics, or the new operating system has a section where it says correlation coefficient or correlate, and that was where your r squared would be located. So you would just need to find it from there. If you're having issues with that, you can always Google the correlation coefficient, and that would be able to find some other information for you to do that. And then the next one would have, we want to use the equation that we have to model what we would have in 2012. So since 2012 would be the year 12, I'm going to take 12 and substitute that into my equation and find out what I would get. So if I do that, I can use the calc button. And if I go over, as long as my equation is in my y equals, I would go to second trace, which is the calc button. I would put in number 1 for value, and I would type in x squared, 12 for x, and that would give me the value of the function at 12. And when I do that, I will get that it's roughly 6,069 people. And again, we're talking about people, so we have to talk about not decimals. And then in order to figure out where it's going to reach, the population is going to reach 10,712. Sorry, getting a text at the moment. Anyways, I know I should put my phone away. But anyways, if I am trying to figure that out, what I'm going to do is in my y equals screen, I'm going to type in the value that they have, which is 10,712. And I'm going to use the calculate button to figure out where they intersect, and then that will give me my y value. You can also use trace if you'd like, but that's going to take a little bit more time. Now, if you have problems with the actual intersection of it, with the two lines solving the line y equals 10,712, and the equation that we have. I can show you that the next time I see you in class. But those should be basic skills that you already know how to do on your calculator. But again, if not, then ask me and I can show you how to do them. And it might be a little bit different based on your calculator for all this correlation, depending upon what operating system you're using. But again, I can always show you that in class, or there should be some information if you look in your book. On page 103, there is some information of how to go about doing some of this in your book. Okay, and there's where I can figure out how to find the calculation. Here's the last one. So I have a polynomial function, and it tells me that my zeros are 1, 1, -4, 6, and 0. And I want to figure out what is that particular function. What I would do is I would take each of these and make it like x equals 1, and x equals 1, and x equals -4, and x equals 6, and x equals 0. When I do that, I then want to move that 1 to the other side. So when I move that 1 to the other side, I would have all of these other informations, all these other factors. And then in order to find out what my polynomial function is, I multiplied these two together and those two together. And then I took those and I multiplied those out, like here. And then I, again, distributed the x, and I went from there to get my polynomial function. So the process isn't too difficult. It's just you might make a lot of sign errors, so be as careful as you possibly can when you're trying to find your polynomial functions. I think that's all we have to say for tonight. We'll talk a lot about more of this tomorrow, and I'll help you with all the calculator stuff. So good luck, and I'll see you next class.